Hello, dear students. For today, we are going to study uh, section 2 in chapter 8. Section 2 in chapter 8 about balancing redox equation. About balancing redox equation. Equation for simple redox reaction can be balanced by inspection. Most redox equations, however, require more systematic method. In the equation, balancing process requires the uses of oxidation numbers. In balancing equation, both charge and mass are conserved. Oxidation and reduction half reaction occur together. The oxidation and reduction occur together, which is like parallel. There is no reduction without oxidation, or there is no oxidation without reduction. Pay attention to this point. The reaction equations are balanced separately and then combine to give the balanced redox reaction equation. This is section 2 about balancing redox equation. Pay attention to this point. The half reaction charge and mass are conserved. In each step, the charge and mass must be conserved. For balancing, we have half reaction method. The half reaction method or an electron method for balancing redox equation consists of 7 steps. Oxidation number are assigned to all atoms or polyatomic ion. You must assign above each atoms or polyatomic ions to determine which species are a part of redox process, which atom, which polyatomic ion is oxidized and which one is reduced. The oxidation and reduction equation are balanced separately for mass and charge. Step by step, by applying these 7 steps, in each half reaction, you must balance separately the mass and charge. They are then added together to produce complete balanced equation. These 7 steps are applied to the following reaction equation. If hydrogen sulfide react with nitric acid, this is an example. If hydrogen sulfide react with nitric acid and the product is sulfuric acid, the products are sulfuric acid, nitrogen dioxide and water. Now we apply these 7 steps on this equation. At first, you must write the formula equation. At first step, you must write the formula equation if it is not given in the problem. Then write the ionic equation. For hydrogen sulfide, its chemical formula H2S. For nitric acid, HNO3. For sulfuric acid H2SO4 for nitrogen dioxide NO2 water H2O. Then after we write the formula equation, then convert this formula equation to ionic equation. Ionic equation. We know that H2S and NO2 H2O do not convert to ionic formula. Do not convert to ionic formula, but nitric acid and sulfuric acid converted to ionic formula. Then we write above each atom or polyatomic ion its charge or its ionic. Then in step number 2, assign oxidation number. Assign oxidation number. Delete the substance that containing only elements that do not change the oxidation state. If there is no changing in oxidation state, delete this atom or this ion. Delete it for the next step. For example, H2S, the oxidation number for hydrogen positive 1, for sulfur negative 2, for hydrogen positive 1, and for so on. For the other elements written all oxidation number. You know how we find the oxidation number for nitrogen, for sulfide, for sulfur, for nitrogen, for hydrogen. In polyatomic ion, we learn this in section 1, how we find the oxidation number. Then, if you look at to the sulfur, change oxidation state from negative 2 to positive 6. The nitrogen changed oxidation state from positive 5 to positive 4. The other substances are deleted. Because there is no changing in oxidation number, oxidation state. Only remain H2S, NO3, ion SO4, ion sulfate, and NO2, because only sulfur change oxidation state from negative 2 to negative 6, and nitrogen in NO3 negative from positive 5 to positive 4. Then we determine which species or which element oxidized and which one is reduced. You know that if the oxidation number is increased, this substance is oxidized, and if the oxidation number is decreased, this substance is reduced. In step number 3, write the half reaction for oxidation. Which one is oxidized, which substance is oxidized, which substance is reduced. Look at to sulfur from negative 2 ion to positive 6. Increase the charge, then sulfur oxidized, Each half reaction equation, you must balance the charge and balance the mass. For this, we write for H2S, because contain sulfur from negative 2 to negative 6. This is sulfur oxidized. This is the sulfur oxidized. Then, step by step, we balance the atom. How we balance the atom? If in the question say, balance the half or balance the half equation in acidic medium, or in basic medium. In acidic medium and basic medium, there is only one substance, one part is differ from each other. In acidic medium, we add hydrogen ion, but in basic medium, we add hydroxide ion. How? Now we explain. To balance the oxygen in the half reaction, to balance the oxygen in half reaction, for example, look at, we add water molecules. Water molecules must be added to the left side. Why we add H2O to the left side? Because on the right side contain oxygen, but H2S, there is no oxygen. In order to balance the number of oxygen, we add the number of water molecules is equal to the number of oxygen on the right side. We must add 4 water molecules in order to balance the oxygen atom. Then the hydrogen atom on the left side is increased, but there is no hydrogen atom on the right side. This gives 10 extra hydrogen atom on that side that of the equation. Therefore, in this case, 10 hydrogen ion are added to the right side, in order to become balanced. Because previous we say in the above we say balance the atoms. Then if the equation say balance the half equation or balance the equation, redox equation in basic solution, if say in basic solution instead of hydrogen ion we add hydroxide ion, and water may be used to balance atom. We balanced the atoms in both sides, right and left side. The step after, balance the charge. Electrons are added to the side having the greater positive net charge. Each side must have the same net charge. Therefore, 8 electrons are added to the product side, or to produce 8 electron. Or on the right side we must write 8 electrons. Why? Because the sulfur from negative 2 to positive 6, 8 electron transfer from negative 2 to positive 6. Then we balance the equation as the following: H2S plus 4 H2O lead to form or produce SO4 plus 10 hydrogen ion plus 8 electrons. In the step, write the half reaction for reduction. We balance the oxidation half reaction, but now write the half reaction, how we balance the half reaction for reduction. Which one is reduced? Nitrogen is reduced. Why? Because the oxidation number from positive 5 became positive 4. How we balance the atoms? Look at to the oxygen atom in both sides. Which one is greater? NO3 is greater than NO2 by 1 oxygen. Then add water molecules to the side that have lower number of oxygen. Then water molecules H2O must be added to the product side of the reaction. Why we add the water molecules? To balance the oxygen atom, to balance the oxygen atoms. Therefore, two hydrogen ion, after we adding the water molecules, there in the other side, the number of hydrogen atom is reduced. There is no number of hydrogen. In this reason, we add the number of hydrogen ion equal to the number of hydrogen in the water molecules. Then NO3 plus 2 hydrogen ion to product NO2 plus H2O. Then by this process we balance the atoms. In each step the half reaction must be balanced. Nitrogen 1, oxygen 3, oxygen on the product is 3, hydrogen 2, and on the product side hydrogen 2. In this step after, we balance the charge. You must balance the charge. How we balance the charge? By the same process. Electrons are added to the side having the greater positive net charge. The left side of the equation has net charge of positive 1. Therefore, 1 electron must be added to the side to balance the charge. Okay, by this process we add electron, the number of electron to the side that contain positive charge. In step number 5, conserve the charge by adjusting the coefficients in front of the electron so that the number lost in oxidation must be equal to the number of gained electron. Look at the number of electrons that lost in oxidation half reaction, 8 electrons, but the electrons in the reduction side or half reduction, number of electron that gain in reduction is equal to 1 electron. Then the number of electron is not balanced. How we balance the number of electron in each half reaction? By multiplying the equation number 1 by 1 and the equation number 2, half equation number 2 by 8 in order to balance the number of electron. After multiplication, then we get the following equation. Then in step number 6, combine the half reaction. After multiplication, combine the half reactions and cancel out anything common in both sides of the equation. Look at, after multiplying the equation number 1 by 1, the equation became like the following. And after multiplying the equation number 2 by 8, the half reaction became like the following. NO3 plus 8 multiplying by 2 became 16 positive and plus 8 electron. After we write this two half equation, cancel out anything common in both sides of the equation. After we cancel multiplying the number, then cancel out anything or any common ion in both sides of the equation. Then we get the following equation. After cancelling, we get 8 NO3 plus H2S plus 6 hydrogen ion, and on the product side 8 NO2 plus 4 H2O plus SO4. Then we get the following equation. Then in step number 7, you must apply this 7 steps step by step. You cannot introduce step to step because you make a mistake. Pay attention to this point, please, dear students. Then combine ions to form the compounds showing in the original formula equation. Then check to ensure that all ions balanced. All ions balanced. The NO3 ions appeared as nitric acid in the original equation. There are only 6 hydrogen ions to pair with 8 nitrate ions. Therefore, 2 hydrogen ions must be added to complete this formula. In order to get 8 nitric acid, we have 6 hydrogen ion and 8 nitrate ions. But in the original equation, there is no 6 nitric acid. We have 8 nitric acid. Therefore, 2 hydrogen ions must be added to complete this formula. And if hydrogen ions are added to the left side of the equation, 2 hydrogen ions must also be added to the right side of the equation in order to become balanced. You cannot add hydrogen to one side, do not add the same number of hydrogen ions to the other side. Then, after we add the hydrogen ion to the left side, you must add 2 hydrogen ions to the right side. After adding 2 hydrogen ions, then we get the following balance equation: 8 HNO3 plus H2S, 8 NO2 plus 4 H2O plus SO4 plus 2 hydrogen ion. We added 2 hydrogen ion to the right side. Then this 2 hydrogen ion, the sulfur ion, appears as sulfuric acid in the original equation. The hydrogen ion add to the right side, then to complete the formula of the sulfuric acid, for sulfuric acid, which is present in the original equation. Then finally we get the following balanced equation. This is the original equation: 8 HNO3 plus H2S need to form 8 NO2 plus 4 H2O plus 4 H2SO4. There is no any matter or any problems if we introduce one substance to, or we write HNO3 before H2S, because in the original equation we write H2S before HNO3, the same thing. Pay attention to this point, dear students. Have a nice time. By this we continue or we finished our subject. Have a nice time.